well, this is the last example that I really have to look at here that I had lost before. Domain and range. This is an exponential function. X is an element of all real numbers. Now, even though this looks as though the graph is touching the x-axis, it actually is not. That x-axis is actually acting as a horizontal asymptote, which the graph approaches but does not actually touch it. It's just with the limitations of the graphing software that it just looks as though it's touching, but it technically would not. The range, y is an element of all real numbers such that y is greater than 0. It cannot be equal to, because that's a horizontal asymptote, and the graph will approach it but never touch it. Zeros and y-intercepts, well, there are no zeros because of the horizontal asymptote on the x-axis, and the y-intercept, y equals 1. Intervals of increase and decrease. Well, it looks like it's increasing along the whole domain from negative infinity to infinity, and it's never decreasing. Discontinuities and asymptotes. It looks like there are none. Symmetry, even or odd. Again, reflected in the x-axis, or say the y-axis. It's not even symmetry. Reflected in the x-axis. It's not odd symmetry, so it is, again, neither. And then the end behavior, as x approaches positive infinity, y approaches infinity, and as x approaches negative infinity, y approaches 0. Okay, so we just have to fill that in the table, and the graph looks something similar to this. The domain, x is an element of all real numbers. The range, y is an element of all real numbers such that y is greater than 0. Intervals of increase, x belongs to negative infinity to infinity. Intervals of decrease, none. Discontinuities and asymptotes, none. Zeros, none. Y-intercepts, y equals 1. There is no symmetry, neither odd nor even. And then behavior as x approaches infinity, y approaches infinity,